Okay, here on the left we have Atomik, the openEHR server we built at Cabo Labs. And on the right we have NoRA. NoRA is a no-code visual client for openEHR REST API implementations that is implemented in Atomik. So we will use NoRA as a client to create data in Atomik. Here we have a pretty clean Atomik instance just installed and has some EHRs. We have 17 EHRs and some contributions. What we are going to do first is try to connect NoRA with Atomik. Yeah. For that, we need to go to the settings in NoRA, create here at the base URL for the REST API. This is the right URL for the test instance of Atomik, and we need to set the authentication method. We will use access token here, and that might be an old access token. I will go to API keys in Atomik and create a new API key that will be accessed by NoRA. We will use by NoRA to access Atomik. I will copy the key, paste the key here because it's different, and save the settings. So right now we have the latest version here of the configuration. It's the same. Yeah, good. So we save that, and we need to create a new workflow. Here in NoRA, everything is visual, everything is point and click. So you need to go to new. Let's create an EHR first. In openEHR, an EHR has an internal structure, data structure, that is called EHR status. You can create EHR status here in NoRA, or you can leave that empty, so the server will create one structure by default, an EHR status structure for each new EHR that doesn't contain an EHR status. So we will leave that empty, and we will go back to the dashboard here. We have 17, and here with this simple step, and this is the simplest workflow that you can define in NoRA, we can run this. Let's run it, wait for the execution, and we have some feedback there that doesn't make sense right now because this is not implemented yet, but we will have a nice report here. Yeah, and if we refresh, we should have 18. Yeah, there's a new EHR there. This is not very valuable for us. We'll try to do something more complex. So after the EHR is created, we want to create a clinical document inside that EHR. But in openEHR, for each clinical document, a template should be defined. The template defines the internal structure and constraints of a clinical document. So we need to first upload a template. So we will choose next, upload template, and this will be a template that we get from a file, and we need to specify the file, and we will choose one of the templates we have here for testing. Let's choose review. That is just a clinical document for an encounter. Then after we do this, next we can create our composition, and our composition should be a file instance. This could be, for instance, a JSON file with a clinical document inside, or we can use the dynamic generator. This generator will create a new composition on the fly, and we'll commit that to the server. And the composition should be based on a template, and we will choose the same template we will upload in the step before this one. So I will choose review. So review, this is the same template. Now this will create a composition that is a clinical document in openEHR, and all the documents should be inside an EHR. But since we have in the same workflow a create EHR step, when this create composition step is reached and executed, it will take the EHR ID from the create EHR. So the create EHR will create an EHR, return an ID, and this will take automatically.id. You don't need to know this, you just need to define the steps on the workflow. As you can see, everything is point and click. You don't need to add any code. You just need to know a little bit about openEHR and how it works, but it's just the general terms and the general structure of openEHR that you can learn in our master class of openEHR. We have that course in our Cabo Labs education website. And now this can be run. So we have 18 EHRs. I will run this flow. We will get a very basic report back. The report could say, for instance, if the template that we uploaded already exists, we will get that warning that the template already exists, but still it tries to upload. It doesn't upload if the template is already there, but it continues to create the composition, and on this step we get everything okay. So here we should see one extra EHR 19. Let's go to the EHR list and let's go to the last one. This is my current local time. And this has basic information about the EHR, and we have two commits here in the EHR. The first commit is for the internal EHR status structure of that EHR that is created when the EHR is created. And the second one is, I think, few seconds after that one, yeah, is the commit of that clinical document, the composition, yeah. So if we can go to the logs, the contributions, we can see there are two contributions, and the second contribution should be for the second contribution is really this one. Let's check the times. This is the last one. So this is the second contribution. We can also extend the window. I just wanted to show you also NoRA at the same time. And here we can see that this is composition, and this is the creation of a composition, and we can see the template ID, the time, etc. So every change in Atomik for an EHR is logged, and every data point, every clinical document is also versioned. So we have here the first version, and the version number is part of the ID of that clinical document. Yeah. Here we can see all the compositions, and this should be the last one. Is this one? This is the one that we just generated, and we can see the details about that one. Yeah, we go back to the details here. Yeah, so that worked. In NoRA, you can define more complex flows. You can create, for instance, loops to create, instead of one composition, you can create 10, 1,000 compositions, and this will be done automatically if you add a looper step. Yeah, and you can also upload more templates, and you can create more compositions of different types of complying with different templates. Yeah, you can also define a looper step and create 1,000 EHRs if you want, with 1,000 compositions inside or whatever. Yeah, I just wanted to show you this very quickly. After this, you can go, for instance, to in Atomik to the query builder, and you can just query the data back. Remember that the composition instance was auto-generated, so it contains random data. So it might not make clinical sense, but it's valid against the definition in the template. Here in the query builder, we need to choose what information we want to retrieve. We want compositions, and we can say we want compositions that are constrained by the review template. That is the one that we uploaded. Inside the review template, we have an entry, an observation for the Glasgow comma scale, and we can choose, for instance, we want the documents that contain the Glasgow Coma Scale, and the data point for the best I response is equal to some values. And all these values come from the definitions in the template. Yeah. So the query builder inside Atomik is also visual, it's point and click, and you can define queries in this way. Let's say spontaneous. I don't know which value was chosen here in the random generated data. So I might get, for instance, for running this, I could get no results. No results. We can say, we can just double check this, and we can say we want one that is equals to none or to spontaneous. So we can, or these two conditions, and this everything is point and click, and the conditions can be as complex as you need. I can test again, and here we got data back, and we have a couple of compositions inside different EHRs. These are the EHRs. Yeah, this is the format that Atomik returns the results for these kinds of queries. Yeah, and you can see for the time that this information of the composition, this is not the composition, doesn't have the contents, it just has some indexing data that allows you to identify exactly which composition it is. This is the one that I just uploaded, because looking at the time, it's just the time that I run this workflow. This might be for a previous test. Yeah. And we can, if we want, we can check the data, and we can also constrain by one EHR. So let's say I want the data for the EHR that ends in 38, B38. So by this, and I want to retrieve the data instead of see the indexing data. And this, we have one composition, and we can see all the openEHR data there in the openEHR format. And we can see Glasgow Coma Scale there. We can search for best I response, and we can see that the value for the best I response is none. So this matches our query criteria. Yeah, because we choose the value is 1 or is 4. Yeah, and this is 1, so matches that node. Yeah, we can do more complex queries. If we save this query, we create that query, we can then use the REST API to execute this query and to get information. And you can, for instance, pass different EHR IDs in the parameters for the REST API for the executing the query. So you can just execute the same query for different EHRs. You can choose also to retrieve or not the data. You can filter by dates, so it has different functionalities. You can also use JSON or XML as an output. We tend to use JSON by default. And you can also, as I said, define more complex query conditions, yeah, criteria. Yeah, so that is a full demo of how you can use Atomik to store and retrieve clinical information, and how you can use NoRA to actually create some test data in your Atomik instance. If you have any questions, you know where to find us. You can leave your questions in the comments, and we will answer them as soon as possible. Thank you. Bye-bye.